In this one, we want to say where they're defined, similar to our last question, and then we want to simplify. Simplify means and you learned this last semester. When you did square roots last semester, you learned that simplifying a square root meant writing it as a mixed radical. So that's a review for that right now. Now for part A, we'll start with defined or not. Does it always work? Does it sometimes work? Does it never work but 0? What do you think? So try some numbers. Try positive numbers. Do they work? Yeah. Try negative numbers. Do they work? So it seems like it always works. It is always defined. Okay. Special note. The square root of a squared is not equal to a always. It's sometimes equal to a, but not always. Why? Because if I had a negative 3 in here, negative 3 squared would be positive 9. The square root of positive 9 is positive 3. So we show that with absolute values. Yes?
I just put in negative 2 for that equation and just told you that the answer is non-real.
For this one right here?
Yeah.
Okay, so now this is a good point, because sometimes we tell our calculator to do something, but we accidentally tell it wrong. Watch as, how did you write it into your calculator?
The square root of 45 times negative 2 squared.
Just like that.
Yeah.
Perfect. Your calculator does order of operations very intelligently. So intelligently, sometimes it's annoying. Because your calculator, you can never yell at it, and you can never say, you know what I meant. It doesn't listen. It just says, well, that's not what you told me. What you just told him was order of operations say, do exponents first. What is 2 squared? 4. Then multiply by a negative 1. What you wanted to write, yeah, error, problem, quit. What you wanted to write here is you wanted to say 45 times, and what's getting squared? The negative 2 is getting squared. So if I want the negative 2 squared, I got to tell my calculator that negative 2 is together in brackets. And all of a sudden, it's happy again. No more error. 13.41640.786. Oh, that was just on the top of my head. I was so close. Okay. So good point on the calculator, because that is very easy to make that mistake, right? So many people, they think, what is negative 1.72 squared? And I'll just write negative 0.172 squared. This will give us a wrong answer on our calculator. Because this will do order of operations. It'll do the 1.72 squared and then multiply by the negative. If you want to hold that negative together with a number and have the whole thing squared, you need to tell it and put it in brackets in your calculator. So a special note, when we square root a squared, it's equal to the absolute value of a. Okay? Number one common mistake. Is just writing a squared as a. It's true some of the time, but not all of the time. Right? I can show you exactly this on your calculator. Right? Some of the time it works. If I go square root of 5 squared, I should just get 5. But if I do the square root of negative 3 squared, I don't get negative 3. The square root and the squared are inverses. We're so used to things canceling out, but there are some order of operation and some rules here that have to follow. Order of operations, inside you would get 9, and when you square root, you get the principal square root, which is always positive. This comes out as positive 3. So since we always want a positive answer, we have this special note saying if I put it in absolute values, that guarantees that it will be positive. So, in this case, I need to simplify the 45. I go to my powers chart. Since I'm in square roots, does 45 divide by any of these numbers? Yes, 45 divides by 9. So I would go back to my question, and I would say 45 is 9 times 5 times, and the square root of a squared, that's the absolute value of a. So simplifying this, I get 3 square root of 5 times the absolute value of a. For b, we'll start off where it's defined. We've got a square root, negative 27, b to the 9. Can you see if b is positive, you're going to have a problem. If b is 0, it's going to be okay. If b is negative, a negative to the power of 9 will be negative times a negative will be positive. So b is defined only when it's less than or equal to 0. Okay. Next, 27. Does 27 break up into a number? Yes. Square root of 9 times negative 3. B to the 9. Okay? If I take one b out, how many b's would I be left with? B to the 8. B to the 8 breaks up perfectly in half to be b to the 4 times b to the 4. So I'm going to just simplify. So I broke things up. 9 is 3. I still would have the square root of negative 3. I'd still have the square root of b. And the square root of b to the 8 is b to the 4. Because b to the 4 times b to the 4, add the exponents, you would get b to the 8. Do I need absolute values? I actually don't. Because even if it's a negative number, to the power of 4 will make it positive. Okay, I'm not going to mark it wrong. Okay, if you added the absolute, it's not necessary here because b to the 4 by nature is positive, doesn't need the absolute values. But if you add the extra absolute values because you want to make sure, no problem. So now when I put everything together, in the end I have 3b to the 4, and inside I still have negative 3b. I'm going to give you your questions, 10, 11, and 14. I think we'll be able to do one more between C and D. If you look at D, do you see D as a cube root? So D is always defined. If you look at C, Z would have to be bigger than or equal to 0 for C. As far as simplifying goes, C is already simplified, so in the matter of time, I'm going to simplify the cube root of 24y to the 5 for you. I hope you can see that the only cube root that divides 24 and I break up my y to the 5 into a y cubed and a y squared. Cube root of 8 is 2. I still have the cube root of 3. Cube root of y cubed is just y. And then I have the cube root of y squared. So as a final answer, I would have 2y cube root, and what's left inside my cube root is 3y squared. Some of you will get very good at going directly from here to here, and I am okay with that. But these require some thinking, so make sure you're practicing and thinking about them, especially with the variables, because it's after you've practiced for a while, it's all of a sudden you're like, oh, I really see what's going on. I can tell you the first time you look at this, you don't see what's going on. You do need to practice. So please take some time to try some of these and have a wonderful weekend.